السلام عليكم ورحمة الله تعالى وبركاته. Hello dear students, I hope you are all doing well. مرحبا بكم في فيديو جديد من قناة اليوتيوب Easy Chemistry for All. This is Mr. Muad, and if you did not join the Telegram group, please do so. Here's the barcode. تقدرون تدشون جروب التليجرام بتحصلون كل الفايلات أو الباوربوينتات وحلول الكتاب موجودة هناك. And share guys and subscribe to the channel so that hopefully many more students can benefit بإذن الله from these videos. So we are still in the chapter of substituted hydrocarbons and their reactions, and we'll go to lesson 3, which is called carbonyl compounds. So في هذا الدرس إن شاء الله, what we want to do, we want to identify the structures of carbonyl compounds. ولما نتكلم على carbonyls أو الكربونيل جروب اللي تكلمنا عليها من قبل في الدرس الأول, نقصد فيها الكربون أكسجين bonded with a double bond. Okay, يعني هاي المركبات كلها فيها هاي الكربونيل جروب. And these compounds include aldehydes, ketones, carboxylic acids, esters, and amides. We want to look into their structure and discuss some of their properties. Okay, بعض خصائصهم و some of their reactions as well بإذن الله. So we can skip this. Okay. Carbonyl compounds. What are carbonyl compounds? Carbonyl compounds contain double bonded oxygen in the functional group. So what does that look like? You have a carbon and you have a double bond to an oxygen. Now all of this is called the carbonyl group. Carbo from carbon, onyl from oxygen. Okay? So any compound that has this group is called a carbonyl compound. How many compounds do have this group or have this group? The first one is aldehyde. Look. The second one is ketone. The only difference here is that you remove H and you put R. And then you have carboxylic acids. Okay. The H here, we'll just add an O to it. You have a hydroxyl group. And then you have an ester, where you remove this H and you put another R dash here. And finally, you have an amide, where you put an amino group instead of the OR. So you put NH2. All of them have the carbonyl group. Can you see it? So all of them have the carbonyl group. Now we will go through each compound one by one, okay? So, what is the name of this functional group? It is called the carbonyl group, okay? Now, the first type of carbonyl compounds is an aldehyde. Now, what's an aldehyde? Aldehyde is an organic compound which a carbonyl group located at the end of a carbon chain is bonded to a carbon atom on one side and a hydrogen atom on the other side. So what does that look like? It would look like this. H here, and then here a star. Now what does this star represent? It would represent an alkyl group like an R, okay, a carbon chain, alright, or a hydrogen atom. And this is the general formula of aldehydes. So CHO, this is where it comes from, okay? Now how do we give names to aldehydes? It's very easy. Aldehydes have the same name as alkanes, but what we are going to do, we are going to remove the E at the end of an alkane, okay, and replace it with Al. Alright? And there's no need to put numbers. There's no need to put numbers for the carbonyl group, like the location, alright, because it's always going to be at the end, alright, because it's always going to be like this. You have an H here. So this is always carbon number 1. So there is no need to put that, okay? For example, you'd have methanol, which is also called formaldehyde when you have one carbon. Ethanol, called acetaldehyde when you have 2 carbons, okay? So have a look here. So how many carbons do we have here? 1, right? So the name should be methane, but we will remove the E and put Al because it's an aldehyde. So methanol. This one has 2 carbons. So it's ethane, remove the E and put Al. this has benzene, right? So instead of saying benzene, we'll say benzaldehyde. You need to remember this, okay? So these are some of the examples that you have in your book. So this is the general formula of an aldehyde. Now, what are the properties أو خصائص الالdehydes? Aldehydes are polar and they have a reactive structure. يعني شديدة أو عنده تفاعلية, and it's polar قطبي. There is positive and negative sides. So polar means you have positive and negative sides. But they cannot form hydrogen bonds with each other, with themselves, because the molecules have no hydrogen atom bonded to the oxygen. Remember, to have hydrogen bonds, it means your oxygen has to be bonded to H. لكن in aldehydes, the oxygen is not bonded to H, so it cannot form hydrogen bonds between itself or among its molecules. That's why they have lower boiling point. Why? Because they cannot make hydrogen bonds with each other. Okay? عندهم lower boiling point, درجة غليان أقل من alcohols with the same number of carbon atoms. So this is methanol, alright? And this is methanol, H and H. Both of them have one carbon, right? So alcohol or the methanol will have higher boiling point than methanol, aldehyde. Why? Because the oxygen is bounded to hydrogen and it can make hydrogen bonds. Now, water molecules can form hydrogen bonds with the oxygen on aldehyde. الحين aldehydes ما يقدرون يسوون hydrogen bonds مع بعض, لكن يقدرون يسوونها مع الماء. So aldehydes are more soluble in water than alkanes, because alkanes are non-polar. So they are non-polar. Okay? But they are not as soluble as alcohols or amides. يعني الالكحولز والامينز عندهم solubility أو ذائبية أعلى في المي من aldehydes, والaldehydes عندها ذائبية أعلى من alkanes. And this is what I told you about being polar. Okay? For aldehydes. This is what I told you about being polar. Now, this one here should be an H. Okay? This one here should be an H, not an R. Just to make sure it's correct. Okay? And this one here has to be a star. Okay? So sometimes they're just showing you a ketone as an aldehyde because they have the same carbonyl group. So don't worry about that. Okay? Now, formaldehyde, an example, which is methanol, like we said, methanol has been used for preservation of samples for many years, حفظ العينات, and it's also used in plastics, in electrical outlets, in tapes, and so on. So these are some of the examples of the uses of aldehydes. Okay. Also, benzaldehyde and salicylaldehyde are or give almonds their natural flavor. Okay, this benzaldehyde and salicylaldehyde, and also if you know cinnamon القرفة, the aroma الريحة وطعم القرفة come from cinnamaldehyde. Okay, and that's it for aldehydes. Now let's go to ketones. So ketones are like aldehydes, but instead of having a hydrogen, they have R and R. So they have the carbonyl group. Okay, they have the carbonyl group, but they have a carbon here and carbon here. They don't have an H. So ketone is an organic compound in which the carbon of the carbonyl group, which is this one, is bounded to R and R, which are شو معنى R itself, so that it's not confusing. Okay, the R represents carbon chains or rings. يعني لما نشوف حرف R معناها carbons, not hydrogen. Okay, that's the meaning that I want to convey to you. So this is the simplest type of ketone. You have a carbon here, and you have one carbon bounded here and one carbon bounded here. So this is methyl groups, right? And this is called acetone. You know it from, it removes nail polish, okay? How do we name ketones? The naming is very easy. It's similar to aldehydes. We will name the alkane Okay, we will name the alkane the normal alkane, but we will remove E and we'll put 1. So in aldehydes we added Al, right? But here we add 1 because it's from ketone, the one from ketone. Okay. Now we need to give a number to the ketone group, like the carbonyl group. We need to show its location. All right. So we give numbers, like it has to be the lowest number. Same rules as we learned in chapter 7. So for example, look here. How many carbons are there? 3 carbons, right? So this is propane alkane, صح? But we have a carbonyl group, and here carbon and here carbon, so it's a ketone because it has this formula, right? R and R. So we will remove E and we'll put 1. Did we finish? No. What's the location of the carbonyl group? 1, 2, 3. So it's number 2. So we should say 2 propanone or acetone. Okay? And this is what is mentioned here. You can read it, stop the video and read it. What are some examples of ketones? You have 2-butanone. Again, you have 4 carbons here. So it will be butane. Remove the E and put 1 and then indicate the location of the carbonyl group, which is 2. We can also call it methyl ethyl ketone. How does that work? So look at the carbonyl group here, okay, and look at this part. This is C2H5, right, which is ethyl. And now look at this part here. This is CH3, صح? So this is methyl. Now, which one is carbon number 1? It's the methyl carbon, right? So we will name it first here, methyl. Okay, and then ethyl, right? And this part here, we are going to say ketone. So methyl, ethyl, ketone. This is another way to give names to ketones, okay? And we already saw 2-propanone. You need to remember that this is acetone, okay? You have to remember that. So what's the name of this? Again, before you do anything, you need to know the general formula. So this is R and this is R, because all of this is R and all of this is R. So this is the formula of a ketone. So you should choose the one that ends with 1, okay? 2-butanone. Ketones and aldehydes are very similar in terms of chemical and physical properties. How do we know that? Because they are a little bit similar in the structure, right? So this is an aldehyde and this is a ketone, right? Both have the carbonyl group. Ketones are polar molecules, but they are less reactive than aldehydes. So تفاعليتهم أقل. Okay? And they are popular solvents. They are used in many solvents, so like polar substances, waxes, plastics, paints, and so on, glues as well. They cannot form hydrogen bonds with each other because they don't have hydrogen on the O, but they are a little bit soluble in water. Okay, and acetone is completely soluble or miscible with water. Miscible معناها يعني يذوب أو يختلط تماما. Okay, and they are polar, as you know. They have positive and negative sides. And now we can come and give some namings to these compounds. So look here, before we finish the parts of ketones and aldehydes, what is this? This is a carbonyl group, right? Here you have H and here you have R. So this is the formula. H and star. صح? So this is an aldehyde. This is an aldehyde. How many carbons are here? 4. So butane. Remove E and put Al, because it's an aldehyde. What about this one? This is carbonyl, right? So carbonyl. And here you have carbon, and here you have carbon, صح? And high carbon, high carbon. So this is a ketone. So what's the name of this alkane? Cyclohexane. So you remove E and put 1. So cyclohexane. hexane or hexanone. Same thing. How many carbons are here? 4. So this is cyclobutane. So you remove E and put 1. So cyclobutanone. Okay, because this is a ketone and this is also a ketone. كيف عرفنا ان هذا كيتون؟ لان هاي الكربون عندها رابطة مع كربون هني وعندها رابطة مع كربون هني, which is like R and R. And that's it for ketones and aldehydes. Okay, so what we are going to do now is we are going to continue with carbonyl compounds. What we have done so far is that we have covered aldehydes and ketones. Okay, now we will go to carboxylic acids, right? So what are carboxylic acid? What's a carboxylic acid? A carboxylic acid is an organic compound that has a carboxyl group. So what's a carboxyl group? Carboxyl group is made of 2 things. It's made of a carbonyl group, which we already know, and it's made of a hydroxyl group, which we already know, the OH group, right? So if we combine them together, we will have a carboxyl group. And that's how it looks. This is the carbonyl group, and this one here is the hydroxyl group. So all of this together is called carboxyl group. Okay? Or it can be abbreviated like this. نختصرها بهاي الطريقة. Because we have C, O, O, and H. So when you see any one, it means a carboxyl group. Okay? And this is the general formula of carboxylic acids. Okay? So carboxylic acids have this general formula. What does the star mean? Star means H أو R. And what does R mean? R means a carbon chain or a ring. Okay? So here we can have an H or we can have an R. Doesn't matter. So you can see the difference between carboxyl and carbonyl. So carboxyl has an OH, carbonyl does not have an OH, right? So can make hydrogen bonds, cannot make hydrogen bonds with each other, as you already know, or you should know. So how do we give names to carboxylic acids? Again, very easy. Okay, it all depends on the alkane name. So you name the alkane, count how many carbons are there, name the alkane, and now you will not change E, you will change ANE. You will remove it and you will add anoic acid. Okay? You will add anoic acid. So for example, look here. You found carboxylic acid, right? Carboxylic or carboxyl group. So you know this is a carboxylic acid. How many carbons are here? 2. So this is ethane, right? So what you do, remove ANE. So remove ANE and put anoic acid. So it becomes ethanoic acid. Now here you have carboxyl group, right? How many carbons are here? 1. So this is methane. Remove ANE and put anoic acid. So this is methanoic acid. Now this is also called acetic acid, and this is also called formic acid, which we should remember, okay? And this is how we give names to carboxylic acids. All right? So what are some of the properties of carboxylic acids? They are polar and reactive. They dissolve in water and ionize weakly. So they are weak acids. Do you remember acids from the last term? So they are weak acids and they produce hydronium ions, remember? H3O+. Alright? So this is the ionization of ethanoic acid or acetic acid, which is CH3COOH, which we know from the last term. So CH3COOH plus water, it will lose an H, right, to water because it's an acid, a bromistid-lowry acid, and you will get a hydronium ion and acetate ion, the negative ion and the positive ion. So these are some of the properties of acids or carboxylic acids in general. They are weak acids, okay? What are some other properties? Carboxylic acids can ionize in water, as we saw, all right? The two oxygen atoms are highly electronegative and they attract electrons away from the hydrogen atom in the OH group, okay? So the hydrogen proton can transfer to another atom that has a pair of electrons not involved in the bonding. So this is what we saw here. So this H can be lost and go to water. This is what they are explaining. They are explaining the reason why. Because the oxygens will pull electrons to its side and H will be kind of free or loose. It can be lost easily. Okay? And you know that when we put them in a blue litmus paper, they become red. Okay? And they are soluble in water. So all of these things we covered in the last term because carboxylic acids are actually acids. Huh? Now, what are dicarboxylic acids? What do you think di means? Di means 2, right? So how many carboxyl group should we have in dicarboxylic acids? We should have 2. So a dicarboxylic acid has 2 carboxyl groups, okay? Has 2 carboxyl groups. So there are some important acids or carboxylic acids such as oxalic acid and adipic acids. So look here at this part. Here's a carboxyl group and here's another carboxyl group. صح? Here's a carboxyl group and here's another carboxyl group. So these are dicarboxylic acids. There are 2 groups. Okay? So some others can have an additional hydroxyl group. Okay? Like lactic acids. So here you have a carboxyl group and an OH group. Okay? So remember, hydroxyl is OH group. And this lactic acid is found in yogurt. Okay? It gives the acidity of the yogurt. Okay? Now these acids اللي هم dicarboxylic, they are more soluble in water than many other acids, okay? And they are more acidic, yani their pH is lower compared to acids with only one carboxyl group. So إذا عندك more than one carboxyl group, you are more acidic, you are more soluble in water, okay? And that's it for carboxylic acids. So you can have a look at these slides. They summarize what we had just talked about, okay? And now we will stop the video and go to the next part of this section. Bismillah ar-Rahman ar-Rahim. So now we are going to the last part of section 3 in chapter 7. We have been talking about carboxylic acids, aldehydes, and ketones. Now we will go to the last types of compounds, which are esters and amides. And this is how they look like, okay? So esters, okay, and amides are, esters are derivatives of carboxylic acids. So in carboxylic acids, we had star here and then OH, right? So instead of H, we will have R in esters. And in amides, we have a carbonyl group and an amino group. So let's start first with esters. So what's an ester? An ester is an organic compound with a carboxyl group, okay? It's a carboxyl group. So what's the carboxyl group? This is the carboxyl group, right? In which the hydrogen of the hydroxyl group, so they're talking about this hydrogen here, has been replaced by an alkyl group. So we remove this and we put an alkyl group, which is an R. Okay? So this is the meaning of the definition. So usually when you have a carboxylic acid and it reacts with alcohol, because this is the general formula of an alcohol, you will have an ester plus water. Okay? So this OH and this H will go together to form water, and this R will take the place of H here. Okay? And that's how an ester is formed. Okay. So how do we give names to esters? So write the name of the alkyl group, okay, followed by the name of the acid with IC, acid, ending replaced by ATE. Okay, so what does that mean? Let me show it to you here. Let's look here. Okay, what does this thing that we talked about mean? So look here. First of all, you have a carbonyl group, right? And then you have here R, صح? Because carbons. And then here you have O and R. So which compound is this? You should know that this is an ester. So this is the R, or the alkyl group that removed the H from the carboxylic acid, right? So we come here and we write methyl. Okay, that's the first part of the name. Now let's go to this part here. How many carbons are here? 1, هني 4 ضرب 1, so 1, 2, 3, 4, 5, and then 6. So 6 carbons, right? So we will write hexanoic, because we are treating this as a carboxylic acid. Remember, it should be hexanoic acid, right? So we are going to remove the acid, and they said replace IC acid with 8. So we'll remove IC as well and we'll put 8. So the final name should be methyl hexanoate. And this is what we have here, methyl hexanoate. Now look at this part here. This is ethyl, and this 1, 2, 3, 4, right? So this should be butane. So just remove the E, okay, and put OATE. Or what you can do, you can write butanoic and use the rule, remove IC and put ATE. So same. So this should give you ethyl butanoate. الإيثايل هاي من وين جت؟ من الR اللي مربوطة بالأكسجين. So ethyl butanoate. Alright? And this is how we give the names for esters. Okay? Now, what are the properties of esters? They are polar, and they are volatile, and they are sweet smelling. Volatile يعني evaporate fast, يتبخر بسهولة أو بسرعة. Okay, therefore esters, because they have sweet smelling, they are used as flavors in beverages, as fragrances, or ريحة for candles, for perfumes, and so many other things. Okay, so esters are used there. Now let's go to the next compound, amides. So amides, and amide is an organic compound in which the hydroxyl group of a carboxylic acid is replaced with a nitrogen atom bonded to it. What does that mean? So this is a carboxylic acid, right? Now this one is going to go, and we will have now an amino group, or a hydrogen, a nitrogen. Okay, so this is the general formula. This is the amide group. Okay, so the amide group is a carbonyl plus amino. So amide is carbonyl plus amino. So carbonyl is this one, and amino is nitrogen. Alright, the star can mean any other thing, right? Can mean H or R, and this one can also mean H or R. So how can we get an amide? We can do that or get that by a reaction between carboxylic acid and an amine, like the ammonia, NH3. So what will happen is that OH from here and H will go together to form water, and then the NH2 will replace them. And this is called the condensation reaction, which we will find at the end, okay? Which we'll have a look at the end. So this is an example of a condensation reaction. And this is how we form an amide, okay? So you have a carbonyl group, and you have the carbon of the carbonyl group is bounded to nitrogen. This is an amide, okay? So how do we give names to amides? The naming of amides is very easy. They are named by writing the name of the alkane. It's like the one for aldehyde and ketones, remember? So we will only remove the E and replace it with amide. So for example, look here. This is an amide group, right? So you should, like this one. Yeah? Because you have carbonyl, and the carbon of the carbon is bounded to nitrogen. So count the number of carbons here. How many are there? 2. So it should be ethane, right? What does the rule tell you? It tells you remove the E and put amide. So the name should be ethanamide. Can you see it? Ethanamide, and it's also called acetamide, and this one is called acetaminophen. You don't need to remember how to give names to something like this, but just know that this one here is an amide. So this is an amide compound, okay? Also this one. You need to know the functional groups, all right? Now, we come to the last part of the section, which are condensation reactions, which we had a look at when we were looking at the formation of amides and also esters. So what's a condensation reaction? It's where two smaller organic molecules combine to form a more complex molecule, accompanied by the loss of a small molecule such as water. So what does that mean? It means you have A plus B, so small organic compounds. They will react to give you a new complex compound, let's say X plus water. So this is a general formula, okay? So you lose small molecules like water. So condensation reaction is also an elimination reaction. Elimination reaction we'll study in section 4, inshallah. So what does elimination reaction mean? It means bonds or new bonds are formed, okay, between two atoms that were not bonded previously together. The most common condensation reaction involves the combining of a carboxylic acid with other organic molecules, okay? So carboxylic acids, they undergo condensation reactions. So to get an ester, if you go back in the video and you saw how an ester was formed, you will remember that we talked about a reaction between carboxylic acid and alcohol. So this is the general formula of a condensation reaction that makes, so this is carboxylic acid, this is alcohol, and this is ester, and this is water. So two small compounds, they will make a bigger or complex compound, and you lose water. This is what we saw in the definition here, right? So this is a condensation reaction. Also, we saw the following, something like this, plus ammonia, right? Which would give us RCOO, sorry. Let's go back here. So this is an amide, this is ammonia, and this is how can we see, yeah, carboxylic acid, okay? So a reaction can be between ammonia and carboxylic acid, and an amide would be formed, okay? So this is actually an elimination reaction, which we saw here. Let me remind you. Yeah, it's a condensation reaction, okay? And also a type of elimination reaction. So this is the example. You need to remember this general formula, okay? And this is the example that you have in a book, and this is the definition that we saw. So when you have two things, they combine, and then water comes out as a byproduct, and this is a complex. مركب معقد أكثر من هالاثنين. Actually, this is aspirin. This is called the condensation reaction. Okay? So these are just summary slides for what we have been talking about. Now let's go to a little bit of practice. Classify each carbonyl compound as one of the types of organic substances that we have studied. We studied 5 organic carbonyl compounds: aldehydes, ketones, carboxylic acids, esters, and amides. So have a look here. What's this? So look, just write the general formula. You have R, صح? And here you have O, R, صح? This is the same as this one, guys. It doesn't matter, right? It's the same. So what should this be? It is an ester, right? This is an ester. So what's the name of this? Again, we said look at the alkyl group. This is ethyl. So you write ethyl. And then how many carbons are here? 2. So ethyl ethanoate. This one here is a ketone because it has this formula, right? R and R. And we already saw it. This is cyclohexane. Cyclohexane. But do we write an E? No. We don't write the E. We remove the E and we put 1. So cyclohexanone. Okay. What about this one? This has the general formula of an amide, right? So easy. Count the number of carbons here. 1, 2, 3, 4. Write butane. Don't write the, sorry, remove the E and put amide, butanamide. What about this one? This has the general formula H and R. So this is aldehyde. So again, count the numbers 1, 2, 3, 4. So butane. Do we write E? No. We remove the E and we put al. So it's butanal. Okay. So this is an ester. Sorry, this should be ethyl. My apologies here. This should be ethyl ethanoate because you have 2 carbons. And this is butanamide. And this is ketone, cyclohexanone, and this is aldehyde butanol. Okay. And this is the end of the lesson. هذه هي نهاية الدرس. أتمنى لكم كل التوفيق بإذن الله تعالى، وأشوفكم في الفيديو القادم بإذن الله. Don't forget to join the Telegram group and share and subscribe to the channel. في أمان الله وبالتوفيق.